Okay, so we've got the setup switched around now, guys, so you can see the plane diameter that I've turned is now closest to the chuck, and the diameter that's unturned yet, or not turned yet, is waiting to be turned near the tailstock for the Morse taper. And if I zoom in, you'll see what I've done there. I've got some aluminium both under and on top of the bar, just so that I'm not making any marks on that bar at all in clamping it. So that's all ready to go. What I've also got in, and this is a bit of an interesting setup, I'll just cut the camera, I'll go around to a different angle and bring you back and show you the kind of setup that I'm going to try and use. It's a bit different from normal, and we'll see how that goes. So I'll just show you that before we start turning. So if you have a look at the setup, the difficulty typically with a setup like this, when you've got a taper that you've put on, and this is only a 1.5 degree taper, so it's not far off zero, but when you're going to use the compound slide and you've got a taper on, typically what will happen is, if you use a conventional tooling setup, you'll be struggling for space up against the tailstock to actually move the compound slide. So if you can see the setup of the tool I've got in there, it's a big old piece of high speed steel, and I've ground it. It's a tool that was already pre-ground to these kind of dimensions. You can see some of the original material on there. I've just given it a clean up. So we've cleaned up both front, side faces and top face, and we've ground a small radius on, probably about 1mm radius, something like that, and I've stoned that, so that's all been stoned, and I'm actually using the front of the tool post as opposed to trying to use the side of the tool post how you would conventionally, which then means you're struggling to get in this gap if your tool's big. But using this approach, I've got loads of room, and it's also brought the whole cross slide back, which has increased this gap, so I've got more room to work. So, and I can do that. It doesn't matter about this geometry because I'm not going up to a shoulder. I'm going to turn this whole length until we've got a taper across the whole length, so it doesn't matter what geometry is on the front of this tool. So we'll give this a whirl and see how it goes. So I've set that up on centre, everything's tight. I'll just get the lathe fired up and we'll start turning the taper on here. So you get the idea. That tool seems to be cutting pretty well. So I'll bring you back when I've cleaned up the full length and we're getting somewhere near finished size. Alright guys, there we go. I'll just zoom you in a little bit. So I've turned that now and I've been measuring sizes at this end, and I'm making an assumption that the tape is still correct. It should be from clocking the compound slide in. And I've taken this to the sort of top limit of the range of sleeves that I measured. So what I'm going to do now is take the tool out. I'm going to put a chamfer tool in. I'm going to put a decent chamfer on both ends now to take the burrs off, and then we'll take it out. We'll remove the live centre and we will trial fit it in the tailstock. Now I don't have any blue, engineer's blue, which would be ideal for this, just to try and see how it's bedding, so we're just going to do it by feel for now, but I'm going to see if I can get some blue on order and just see if we can blew this up. I've got some Sharpie black, but I don't think it will stay wet long enough for me to get that down inside here. We might give it a go, but I'll get it chamfered first and we'll just trial fit it. So we'll just take the turning tool out. We'll drop the chamfer tool in. Realised you can't see any of that. Let me just zoom you back out a little bit. So just chamfer that now. Nice. Right. Take the tailstock out, the live centre out the tailstock, sorry. We'll just make sure this is clean. That's pretty good. That's the lightest, the very lightest tap in there, and that's holding it. So I'm sure if I give that a good old thump in there, that will fit. Yeah, I can't move that. It's not coming out. Pleased with that. So it's somewhere near where it should be. I need to blue it or black it. I'll just see if I can do something with a Sharpie and see if we can get an idea of where that's bedding, but I'm just looking for any marks to see if I can see any marking on there. But anyway, for now I'm going to call that done from a turning perspective. So that's got the Morse taper 3, the what's supposed to be 20mm diameter bit done, the overall length's done, and this step diameter's done. So I think I'm going to remove that dog from there now, and the next job now is to move this particular piece onto the mill, and we've got a slot to mill through this plain diameter portion. So that's what we'll do next. So I'll bring you back when we're at the mill putting that slot in. Okay guys, we're over at the mill now, so this is going to be the first, it's only a small test of the mill since we've done the rebuild, but it's probably just as well, just to break it in gently. So what we're going to do now is, I've loaded up the Tailstock Die Holder arbor in the vise. I set it up on some parallels and I've removed the parallels because I'm going to be going right through. I'm going to need to go really carefully with this because I've got basically line contact both sides gripping this. I've got a good hold of it, you know, I've tightened the vise right up as tight as I can. With the equipment I've got, there's no other way of me holding this just because of the shape of it. With other equipment there would be other ways of me doing this, but with what I've got at the moment in the workshop, this is really the only way I can hold it. So I'm just going to go really steady with it, and hopefully that will be enough grip on the vise not to move. So basically, when I've stopped kicking the tripod, what we're going to do here, hopefully this is showing, we're going to put this slot in here into the parallel section of the diameter. So it's on the centre line, and it's, you know, the centre of the hole from this end is 10 millimeters in, and the overall slot length is 60 millimeters long, centre to centre. So what we're going to do first, I've got my edge finder in, so we're going to edge find the fixed jaw of the vise. I've already written on the vise what my centre line is based on the diameter of the bar, which was slightly under the 20mm, as I've discussed before. So that's my centre point. So we'll touch on the fixed jaw, we'll set a 0, we'll wind over to the centre point, and then we'll touch on the end, set a 0, and wind in my 10mm. I'm then going to centre drill a hole. I'm going to drill through at 5.5mm with a drill, both ends of the slot, and then I'm going to then drop an end mill in to then just gently peck down and keep running up and down the slot to remove the material. Now unfortunately the end mills I've got that are the right diameter for this slot don't have a long enough flute length really to get all the way through, so I'm going to have to do a bit of jiggery pokery, I think, as I get near the bottom. I have got a ball end mill that will just about get through, so I'm going to use a flat end regular end mill to get as far as I can, and then I'll switch out for the ball end mill to see if I can get right the way through. If I can't, I'm going to have to spin the part round 180 degrees, set back up, and then I'm going to probably need to use my 5.5mm drill again to reorient the part, either that or a clock, one way or the other, to set it up and come at the other side of the slot, you know, from the other side. So that's what we're going to do. So I'll just put the drawing back, and I'll bring you back in a moment when we're setting up for the slot. Okay, here we go. We'll get the edges found and get the dial set to 0. Okay, that's the first hole position set. We can go a bit faster with this centre drill. speed that up a bit. Right, I think it's 70mm. Just going to check my drawing. No, 60mm. Good job I checked. 60mm hole centres. I'm just checking that's not moved, which is good. That's my 60mm. Double check that, make sure I've not made any silly mistakes. Yep, 60mm. Right, so it's done with the holes. So what I'm going to do now is take the chuck out, put the collet chuck in, set the end mill up, and I'll bring you back when we're starting to do the milling. Okay, we're back. We've got a 6mm end mill in there, and this slot needs to finish up 6mm dead on to 6mm and 50 microns, something like that. So hopefully this will be within that range. It should be no smaller than 6mm, but it will be slightly bigger than 6mm, I would think, especially if I have to come at it from two sides. So we'll start with that and see how we get on. I'm basically just going to pitch across side to side and probably take 1mm depth to cut, something like that. This is EN24, so it's quite, you know, it's tough material. As I said before, I don't want it moving in the vise while I'm cutting, so I'm going to have to take it fairly steady. I might even have to go less than a mil, but we'll see how it cuts. It's not going to cut much at all at that speed, is it? So you get the idea. I'll keep plugging away at that, and I'll bring you back when we get somewhere near either breaking through or when I need to change this end mill out for the ball end one that I've got that's got slightly longer flute length on it. Alright, there we go guys, I've just poked through. So I thought I got the camera running, I didn't have. What I'd done was I got just past halfway through on the first side and realised that with swarf entrapment and also the length of flute there was no way I was going to get any deeper, so we took it out, deburred it, flipped it 180, and what I did was put the drill that I used back in the collet but the other way up. So I gripped on the drill and the bottom part of the shank, so you know the first part of the shank here in the collet, dropped the part back in on the parallels, brought the drill down until it just located in the drilled hole section, tightened the vice up, double checked it, put the end mill back in, and then I've just been cutting the same way either side, and I've just poked through there. So we'll just wind this out now. I'm going to leave it on centre line just in case I do need to put it back in for any reason, but I don't think I will. At the end of the day, this is only a clearance slot for a bolt to go through, or a stud to go through. So there's nothing too critical about it, despite the fact I've toleranced it to minus nothing plus 50 microns. That was a bit of wishful thinking, I think, when I had the pencil in my hand. It's really not necessary to be that good. But the good news is, well, two bits of good news. One is we've got a slot all the way through, which is what I wanted, and the second bit of good news is the mill's performed really well, no nasty noises or anything horrible. So that really concludes the manufacture on this now. That's complete, that unit. So I'll probably upload this as an episode on its own, the first episode in the series. I'm just going to deburr that. I'm sure you guys don't want to see me do that. I've done that side already, and what I used was a needle file to start with, and then I used the Noga tool just to run round and just whip the burrs off and put a nice break edge all around the slot. So I'll do the same on this side that we've just machined, and we'll call that part finished, and that'll be the end of this first episode. So as always, thanks for watching, thanks for subscribing, much appreciated. If you've not already subscribed, please do so, because it will help the channel. And I'll join you on the next episode when we'll be picking up the next piece I'm going to do in this series. Will be the sliding piece that goes on here, that's kind of the cartridge then that will hold the whatever unit I want to stick on the front, as I described earlier in the episode. So yeah, thanks for watching. We'll catch you on the next episode very soon, doing the next part in the series.